Okay, in today's video we're going to look at angles and their relationships. So we're going to look at a lot of definitions and look at some examples. Okay, so first of all we're going to start with a ray. We are talking about it's got an endpoint and it goes in one direction. It would look like this. We would have, in this case, we would call this ray AB. And what you need to do is you need to make sure that you say the endpoint first. Okay? You might also see this as ray AB, written like that. Another thing, and I'm going to erase that so I can put this in there, but include this notes, just add this to whatever we have already. I'm probably going to zoom in here in a minute to make sure I included all. The other thing you need to make sure you look at about rays, what looks to be a line right here, we're going to go ahead and say that this is point A, point B, and point C. We could also say that these are opposite rays. The rays that would be opposite would have endpoints of B. For instance, we could call BC a ray, and that would be this ray. And another opposite ray could be ray BA. Okay? They are opposite rays going the opposite direction from each other. Okay, let's look at angle. This might be a little easier to do. We have it's named with a capital letter or a number at the vertex. For example, this angle that we have right here, we could call that angle 1. We could also call that angle B, but you'll often see it with 3 letters, angle ABC, with that middle number being the vertex of the angle. Well, what's the vertex? The vertex is right there. Okay, we have the interior part of the angle, and we have the exterior part of the angle. Okay, and obviously that is a side of the angle. So when we're talking about that, that's what we're talking about. Okay, let's talk about acute angles. Acute angles, that's an example of one. And the measure is less than 90 degrees. Okay, a right angle is going to look like this, and it's going to have a measure of 90 degrees. Probably all review for you here. An obtuse angle, there would be an example of an obtuse angle. It's going to have a measure greater than 90 degrees. And the last angle we're going to look at here is a straight angle. Basically, it's a line. But we also can say that it has opposite rays. and the measure of a straight angle is 180 degrees. Okay, so now let's look at some definitions and properties of perpendicular lines. They intersect to form 4 right angles. They intersect also to form congruent adjacent angles. And the symbol for perpendicular looks like that. Okay, probably familiar with that. And let's determine here for an example where we're going to determine whether the statement can be assumed. Let's look at angle XAY. So we're starting here, we're looking at XAY, that angle right there. Can we assume that it is equal to 90 degrees? Well, you know, it looks like it is, and it probably is, but since there is no symbol on here to tell us that it is, if it was for sure, our picture would have this little box right here telling us that it is 90 degrees. But it does not, so since it doesn't, for the sake of what we do, we cannot assume that that angle is 90 degrees. Okay, what about UAX? Let's find that. UAX, so we're looking at this angle. Is it congruent to SAZ? This angle. Basically, are these two angles equal to each other? We can say yes, and before I explain to you why we can say yes, we're going to talk about the definition of vertical angles. What vertical angles are two non-adjacent angles formed by two intersecting lines. Example of that: non-adjacent, that means that these two angles are equal to each other. Vertical angles are, remember our symbol for congruent is that right there. So why is this right here? Why can we assume that? Well, if you'll notice, these are two intersecting lines and these are vertical, so by definition we can assume that they are congruent. Okay? Alright, complementary angles. Complementary angles, two angles with a measure that add up to 90 degrees. One example of two complementary, if I have angle 1, angle 2, and this is 90 degrees, that's one way of looking at it. Now, another way, these two angles are also complementary. This angle is 60 degrees, and this angle is 30 degrees. They do not have to be connected in order for them to be complementary. The two angles simply have to add up to 90 degrees. Supplementary, very similar concept, except they add up to 180 degrees. Again, these two angles are supplementary. They add up to 180 degrees. But also, if I had this angle being 100 and this angle being 80, these are supplementary because they add up to 180 degrees. Okay, next up we have adjacent angles. These are two coplanar angles that have a common vertex and a common side but no common interior point. So what are we talking about there? There are two angles that have a common vertex. Remember, this is my vertex. They have a common side. We're talking about this side. They have that in common. but no common interior points. That means that there is not a point inside here that is also inside here. Basically, two adjacent angles. They share a side. A linear pair. This is a pair of adjacent angles with non-common sides that are opposite rays. And what does all that mean? Well, we're talking about these are the two non-common sides that are opposite rays. They're adjacent because they share a common side. We'll call this one angle 1 and angle 2. We also know that these angles, when we add them, they equal 180 because it's a straight angle, which means that these two adjacent angles are supplementary. They add up to equal 180 degrees. All right, are all supplementary angles adjacent angles? No, absolutely not. We looked at an example. If I had an angle here that was 100 and an angle over here that was 80, these are still supplementary because they add up to 180 degrees, but they are not adjacent. Okay, let's look. Okay, here we have a drawing, and we're needing to answer some of these questions. Name a pair of adjacent angles. Well, this would be best not to name it by the vertex, so we're going to use 3 letters to represent each angle. We have BFA, and CFB. They are adjacent because they share this common side. Okay. Another one that we actually could find another one here. We have also CFD and what's one that's adjacent to it? DFE. Again, they're adjacent because they share this common side. So we'll just look at those examples. Name a pair of vertical angles. Remember, these angles are formed by two intersecting lines. We have intersecting lines AD and BE. That means these two angles are vertical lines and also congruent. So angle DFE and angle BFA are also vertical angles. You know, we could talk about these angles. These angles also are congruent and vertical. So if you want to put BFD and BFD, which is this angle, and AFE, which is this angle, yes, those are congruent. And they're also vertical. All right, looking at the next question, C. Name a pair of complementary angles, two angles that add up to 90 degrees. Okay, right here we definitely have a 50-degree angle and a 40-degree angle. Those two add up to 90 degrees. So we're talking about angle AFB and angle BFC. Those are complementary angles. They add up to 90 degrees. Name an angle that is supplementary to CFE. Well, let's look at that. Where is CFE? CFE is right here. And we need to find one that is supplementary to this. But what is the measure of this angle? Well, we actually could figure that out. This is 40 degrees because they're vertical angles. So 40 plus 90, that means the measure of this angle, this says that that angle is 90, so we're looking at 130 degrees. Supplementary would be 180, so we need a 50-degree angle, which BFC is 50 degrees. So angle BFC is my answer. The fact that they make a straight line right here tells you that this whole thing would have to be 180. So we could have gone 180 minus 50 to know that this angle was also supplementary. Name an angle that is supplementary to BFD. Let's find BFD. BFD is right here. Again, same situation. This is a straight line, so this angle plus this angle would make 180 degrees. That angle is AFB. Name an angle that is supplementary to CFD. CFD is right here. It's 90 degrees, so I need to find an angle that's 90 degrees. And this one right here is 90, which we looked at earlier. So angle CFA would be supplementary to that. Name a pair of non-adjacent angles that are complementary. We're looking for two that add up to 90 that are not adjacent. Well, our example that we used here, these two angles were adjacent. They shared this common side. So one thing we talked about briefly a minute ago was the fact that these were vertical, and remember, vertical angles, or those were intersecting lines, so vertical angles are congruent. So that one's 40. That means that I'm looking at BFC is 50, DFE is 40, those add up to 90, so those are complementary. So my answer is angle BFC and angle DFE. Okay, down below we've got a few questions. What is the measure of angle DFE? Explain how you find the measure. Well, we're looking at the same drawing. Let's erase that. So see if I can. I'm trying to erase here. Oops. It's not letting me erase. All right. Well, we are looking at. Let's see. I'll try and come up with a different ink color. We are looking at DFE, trying to find the measure of DFE. Here is DFE. Well, we already found that it was 40 degrees. We said it because it was vertical from this angle right here. So my answer, oops, I would say, we said 40 degrees, and my answer would be it is vertical to angle, the vertical angle was AFB, which makes them congruent. Okay, 2B, are CFB and DFE vertical angles? Let's look at that. CFB is right here. This angle, and what is the other one? DFE. Where is DFE? Are these two angles congruent? We're looking at these. Well, one is 50, one is 40. So I'm going to go ahead and say those are not congruent. No, they are not vertical. And you'll notice they're not vertical because the two lines that form them, it's formed not by two intersecting lines. Do we see that? We have more than, we don't have the two intersecting lines to create those two angles. It's formed by actually 4 different segments. So my answer here would be no, they're not vertical because they are not created by two intersecting lines. And the last ones are BFD and AFE vertical. Well, let's look at this. I wish I could erase. I don't know what the problem is with my eraser right now. Let's see. Well, there we go. Well, at least this works a little bit better. BFD is right here, and AFE is right here. Are those angles vertical? They are vertical because they are formed by these two intersecting lines. So my answer to that would be yes. Line BE intersects line AD, forming the two vertical angles. Okay, that's all we have. Hopefully this helps with your assignment working on angle measures and relationships.